2-3 is biconditionals and definitions. And I know, again, definitions sounds like English. I get it. But at the same time, it's using conditional statements. Yeah, Raven.
Can I borrow a stylus?
If I have one, hold on. I have no idea what I was just saying, but biconditionals. So a biconditional is this, okay? A biconditional is a single true statement that has a true conditional and a true converse. So your original statement and then the reverse of that statement are both true, with the phrase if and only if, okay? You may write that phrase every single time as IFF, okay? If you write IFF, I know you mean if and only if. If you write IF, it's wrong. So just make sure you do if and only if, okay? IFF. So for a biconditional, what you're doing is making sure that both statements are true, and then rather than have to write two separate statements, we can just write it as one if and only if statement, okay? So let's say my conditional statement is this. If the sum of the measures of two angles is 180, then the two angles are supplementary. Is that true? If the sum of the measures of two angles is 180, then their sum is supplementary. That is true, right? So this is a true conditional, okay? Now, if the converse is also true, then we can write a biconditional so that it's one statement that says it all, okay? So the converse of this would say what? Yeah, Daniel.
If two angles are supplementary, then they add up to 180.
Right. If two angles are supplementary, then their sum is 180. Okay, if two angles are supplementary, then their sum is 180. Is that true? If these two angles are supplementary, they have to have a sum of 180. True? False? It's true. Okay, so this is when we're allowed to write then, if it's true and true, you may write a biconditional. And the way you write a biconditional is you take out the if then and you put in if and only if. Okay, so I'm going to take away my if, I'm going to take away my then, and I'm going to put in if and only if. So we're going to say, and you may do it, technically you may do it from either one. So I can take out the if here, I can take out the then here, and just put an if and only if in right there. I usually do it from the original conditional. But technically, because it is reversible, you could do it from either, okay? But I'm going to use this first one. So we would say the sum of the measures of two angles is 180. What's going to come here? If and only if, IFF. The two angles are supplementary. Okay, and in the homework, it's going to tell you, give the original, give the converse, and then can you write a biconditional? I'm totally fine with you thinking through the original in your head, thinking through, because the original is going to be given, right? I don't need you to write out the converse. If you can say the converse and figure out if it's true or false, that's fine. And then if it is true, I want you to write the biconditional. But I don't need you to write 5 statements for one question, okay? If it's true, just write the biconditional, all right? They're going to ask you to do more. Just hear me on that. Okay, the way we write a biconditional in terms of P and Q, like we did before, remember before it was if P then Q, and then the converse was if Q then P, and then the inverse was if not P then not Q, and then the contrapositive was if not Q then not P. The way we do it for a biconditional is this. So if P then Q has to be true, And if Q, then P has to be true. And if both of those are true, then we can say this statement here, P if and only if Q, okay? So it says right there how you say it, but that's how we would write it if we're doing a biconditional. You put the arrows going both ways instead of just the one arrow, okay? Okay, so let's say I give you a biconditional. Could you write a conditional and a converse from that? So if I said this, array is an angle bisector if and only if it divides an angle into two congruent angles. So there's an if and only if in there right now. We need to take that out and put in what? Just the reverse of how we wrote the biconditional. What did we take out for the biconditional? We took out if then, right? Now we're going to put the if thens back in and take out the if and only if. So this is going to go away. We're going to put an if at the beginning and a then where my if and only if was, and then we'll just write the converse of that. So it's going to be if array is an angle bisector, then it divides an angle into two congruent angles. Notice the shorthand. You are welcome to use that. If array is an angle bisector, then it divides an angle into two congruent angles. Okay? What would the converse of that be? And be careful when you write a converse with this word, because we want to know what it is. So how would you say that? Yeah, Daniel.
If array divides an angle into two congruent angles, then it is an angle bisector.
Right, so the it they're talking about is the ray, right? So we're going to say if array divides an angle into two congruent angles, then it's an angle bisector. Okay, so from biconditional to conditional and converse, or from conditional to biconditional. It's just kind of the reverse of each other. Any questions so far on that? Okay, then we're going to get a little bit into how good definitions work. In order for something to be a good definition, there's three qualifiers that we're going to use, okay? The first thing is you have to use clearly understood terms. Okay? Some of you in this room will be able to answer this question, but I think a majority of you will not. What's a snorfplat?
A what?
A snorfplat. Yeah. It is a made-up word, but it is something as a made-up word. How about a dingle hopper? It's a fork, right? We don't know that. Well, we do, but most people in this room don't know that, okay? What's a snorfplat? Do you remember? A snorfplat. He had a dingle hopper and a snorfplat. It's a pipe, right? It was a pipe. It's the seagull. What's his name?
It's not selection, it's, oh, shoot, hold on.
Do you know what movie we're talking about? Little Mermaid. It's what? Scuttle. Yes, Scuttle. So Scuttle did not use clearly understood terms for his fork and his pipe, right? No one knew what they were. He made them up. Okay, so when you give a definition, it needs to be words that are clearly understood by all, right? Second thing, a definition that's a good definition has to be precise, okay? You don't want to use things like large, because what is large to an ant is very small to us, right? You don't want to use words like sort of, okay? Or almost. You want very precise terms, exact terms, okay? And then the third thing, the reason we're talking about all this, is a good definition is reversible, which is what a biconditional is, right? It's a conditional statement that is reversible. So basically, if you can write a biconditional from a statement, it's a good definition, okay? So we're going to talk through just a couple of statements and are they good definition type things. So this is the next page for me. You might have them all just in order here. Can I move on from this one? All right. So is the definition reversible? And if it is, you should be able to write a biconditional, okay? So here's the definition given. A quadrilateral is a polygon with 4 sides. So basically what we're looking for is, can you write that as a conditional statement? And then can you write the converse of it as well? Because if the conditional and the converse are both true, then yes, we can write the biconditional. So can anyone turn this into a conditional statement for me? An if then? Yeah, Daniel.
If quadrilateral is a polygon that has 4 sides.
Close. I would flip that around a little bit. I would say, yeah, Hannah. You could say if a polygon has 4 sides, then it's a quadrilateral, okay? Or I would say for the first one, and you could say that for your first one, and then the converse would be what I'm about to say. But your 2 things that you're trying to see, do they work out, are the quadrilateral and the 4 sides, right? Not the polygon and the 4 sides, because not every polygon is going to have 4 sides, but every quadrilateral should have 4 sides. So we would say if a polygon is a quadrilateral, then it has 4 sides, right? So you just have to stop and think about what it's saying and make sure that how you're writing it makes sense. So if a quadrilateral is a polygon, or if a polygon is a quadrilateral, then it has 4 sides. Is that true? It's true, right? If a polygon is a quadrilateral, then it has 4 sides. Okay, the converse of that would be what? If a polygon, what Hannah said, has 4 sides, then it's a quadrilateral. Is that true? Yes, right? So if both of those are true, which they are, so that's what we just did. We checked the conditional and its converse for their truth value. They are both true. Then we can write a biconditional. So the biconditional would say a polygon is a quadrilateral. What comes next in a biconditional? If and only if. IFF, if and only if, it has 4 sides. Okay, questions on that? Okay, tell me this then. Are these good definitions? A fish is an animal that swims. If it's not, you should be able to give me a counterexample. If it is, you should be able to write a biconditional for it. A fish is an animal that swims. Who thinks that's a good definition? Who thinks not a good definition? I got 3 opinions, 4 opinions. Not a good definition. Why? Gracie, why is that not a good definition? Okay, a shark swims. Is a shark a fish? A whale? A whale is not a fish. A whale is not a fish. So a fish is an animal that swims. Birds swim, right? You go to the pond and there's ducks that swim. They dive and swim around in the water. So there's a lot of counterexamples you could give. But we would say, no, this is not a good definition, and you could give a whale. Technically, you need 1 counterexample, okay? So whale would work. Or you could do a duck, or you could do any other animal that swims. I've seen, crocodiles, right, swim. Or I've seen cheetahs swim on those nature shows. So give a counterexample. Number 2, rectangles have 4 corners. Yeah, not a good definition. Why? Squares have 4 corners, okay? A square is a rectangle. So yes and no with that. That's true. Yeah.
It could be like
Right.
not.
That has 4 corners, yeah. So this would not be a definition. It's not precise enough, right? They don't give enough detail to it, because something like this, you could say has 4 corners, and that's definitely not a rectangle, okay? So this could be your counter, and for a counter example, guys, you're welcome to draw me a picture. If a picture makes more sense than a word, draw me a picture. That's totally fine. Number 3, giraffes are animals with very long necks. Is that a good definition?
No.
Why not? Why not?
Oh, since lots of animals have very long necks.
A lot of animals have very long necks. Here's the issue, right? Very long. That is not, what was the term? Precise. That is not precise, right? That's like an almost. Very long is a relative term. So this would be no, and a counterexample could be
A lamprey.
a what?
Sea.
Sea, a sea lamprey. I'm gonna have to talk to my Zeke about that. Eels. Does an eel have a neck? It's like a big neck, huh? I always think of, what were you gonna say? A flamingo or an ostrich, or a, how do you spell that? C. Is it lamprey? Is that what you said? Like that? I'm gonna have to ask my Zeke about that. Okay, number 4. A penny is a coin worth 1 cent. Good definition? That's a good definition. It's precise. You could reverse it. A coin worth 1 cent. If a coin is worth 1 cent, then it's a penny. If a coin is a penny, then it's worth 1 cent, right? So this would be yes, that's a good definition. Okay, questions? Yeah.
What about like a coin in another country that's not a penny that's worth 1 cent in the U.S.?
But it's not, I mean, I get what you're saying with that, but there is no coin that is always worth the same value as a U.S. coin, right? Because currencies are always changing. So at some given time, I guess you could say that's true.